Okay, we are live, team. Hi, how's everyone going?
Awesome. Yeah, no, super good. Can you hear my keyboard?
Yes, a little bit, but no worries. Okay. Okay, the chat is ready. We start having people here. So let's get started. So hello, everyone. So for today's webinar, we have a really special guest, Matt Carey, with us. He is enjoying his last day on vacation, but wanted to join us in this special occasion. Not sure if you want to give 5 cents, Matt, to introduce yourself.
Yeah, I'll introduce myself a little bit more later on. But yeah, I'm Matt. I work at a consultancy in London called Alios, and I do a lot with serverless and with AI and the intersection between like Gen AI applications and how you can build in like an event-based paradigm. So I do a bunch of stuff like that, very similar to these guys. And yeah, it's all good fun. Happy to share something about what I've been learning the last year or so.
Nice. Welcome to the webinar. And you just mentioned serverless and AI in the same sentence. So I guess no one is perfect for this webinar, or no one is best for this webinar than you. So welcome. Let's see what we have prepared for today. So just as a little intro, we'll give a few cents about who is serverless or what is about serverless guru. Then a deep dive into Langchain by Matt Carey. I'm really excited to hear all the things you've been learning on serverless and AI during these last years. And then just a few intro or few options that all participants can have regarding the serverless API that everyone is supposed to build for this hackathon. Then just about serverless guru. Sam has already given a really good explanation about who we are in the last few webinars, but just as a few pointers or bullet points to know is we love challenge, we love serverless, we try to be in the forefront of serverless innovation. So if you think that's something we can help you with, just reach out, feel free to talk with us. And what a better place to talk with us than on our Discord server. I know most of you are already in there. We have a community channel just to speak anything serverless, even random, even some memes and random, but feel free to just hop in, grab a screenshot or a photo of the QR on the screen and join the community to be able to talk to serverless gurus directly. Also, we have here 2 different channels, just hackathon specific. So if you have any questions regarding the hackathon, feel free to just jump in and ask anything you need. Regarding the submissions, it's now live, the forum. Mirsad has been working hard on having the update there. So feel free to just same link, so hackathon.serverless.guru, where you registered for the hackathon. You can now enter the submissions. We still have a few days left until December the 17th. You will also have here the nice countdown to work with your entity about how much time you have left to do the actual submissions, but feel free to grab a screenshot of it so that you guys can start sending us your submissions. We're eager to see what everyone has been playing around with and developing. And then let's just dive right into it. Let's give space for Matt to explain everything Langchain related. I'm sure it will really help everyone with developing everything. So yeah, let's bring your slides up and let's get started.
Sweet. Awesome. Awesome. Over to me. Right. So I guess a lot of people here have been working with, probably know what Langchain is, or they've looked at it already. If you've been building a serverless API for the hackathon, which I hope a lot of you have been, it's really cool, then you've probably had a look into it. But we're going to go over a bunch of stuff about what it is, why it's useful, why like maybe directly calling the OpenAI API or Bedrock API is probably not the best thing to do for a majority of use cases. And actually, you can save a lot of time using Langchain. We can talk a little bit about the end about where it gets difficult, but I've got some brief slides that we can go through that will cover the majority, and then over to questions really. So yeah, building with Langchain, the hows and the whys. So just really quickly, who am I? We brushed on it a bit earlier, but I'm Matt. I'm a community builder based in London, although at the moment I am in South Africa. I do a lot of like open source Gen AI applications. So I was part of the first few people working on Quiver, which has now got 25,000, I think, or 28,000 stars on GitHub. Insane project, blew up. One of the first like chat with your docs projects that really like gained some traction in the community. We also spun off a separate project that became Genos GPT that, yeah, it was really, really cool. And I've been doing a bunch of my own work with something that I'm calling Orion Tools. So including that is CodeView GPT that some of you may have heard of. We just hit 1,000 stars on GitHub, which is pretty sick. And yeah, I run like Serverless London Meetup and Gen AI London in, yeah, meetups in London. So yeah, hello to everyone in the chat. Feel free to drop your questions in the chat and we'll get to them afterwards. This is no means like a all-encompassing chat about Langchain. There's so much to go into. There's so much to talk about, and it's constantly evolving. It's community-driven, as we will see in a second. So yeah, like really quickly, what is Langchain? I don't know how fast people are at typing, but if you have a really quick answer, you could type in the chat. Give it a second, and then we'll leave the answer. Sweet. Okay, so Langchain is a framework for developing applications powered by language models. That's what they say, and that's pretty much what they do. So they provide a bunch of helpful classes that allow you to interact with different parts of your Gen AI application. So maybe vector stores, loaders to actually load some context, even individual prompts, as we'll see later on. They do a bunch of stuff with agents, more and more moving forwards. The term agents has been a little bit overused, but we'll see what they mean about agents in a second. And actually, obviously, the underlying LLMs, whether that be completions-based LLMs or embeddings LLMs, and yeah, and they combine it all into what they call chains. So we'll talk about it in a second. So, but firstly, like very briefly, why use Langchain? What are their selling points? So really, it's open source. So it's open source software. It's pretty like nice. Bugs are fixed very, very regularly. The Langchain team decide what direction they want to go in, but then it's up to the community to implement a lot of things, and they do a really good job. Langchain's got a silly amount of stars on GitHub, and it's consistently one of the like if you look at the PR velocity, it's insane. They're building super, super fast. So all the newest like technology in the Gen AI space, DeepMind releases a paper about take a deep breath prompt. Langchain implements it like an hour and a half later. Really, really fast. So another reason, Langchain from the very beginning have defined a bunch of a ubiquitous language to do with Gen AI and specifically Gen AI apps when this sort of thing didn't really exist. Langchain, we've got to remember, is only just over a year old. They celebrated their year's birthday about a month ago. And Harrison Chase and the team have done really good work in defining what things actually mean. So a loader does kind of what it says on the tin, but like where does a loader start and say like a transformer stop? Something like that. And Langchain really defined this language. Retrievers, agents, tools, they have their own definition of an agent that maybe is different from other people's definition. But because Langchain is becoming the largest of these sort of ecosystem frameworks, if we take their definition, we're all going to know what we're talking about. So I think it's pretty cool for this, and it's like sort of the new age of tooling. They get to do this, and it standardizes-ish the interface to interact with LLMs and other providers, whether that be vector stores, even like memory stores. So like serverless cache, like Memento can store memory, whereas other like maybe Weaviate would be like a better vector store. There is differences there, and that comes back to the language. And there's so many providers that you might want to interact with. Like now you can even you can use an agent to interact with a tool that can call AWS Lambda. That's like many different pieces there. And Langchain standardizes all of those interfaces. So you can have one standard interface that will call AWS Lambda. Yeah, it's crazy to think it's only been a year. Yeah, a year and a month. And I think Llama Index, they celebrated their year birthday like 2 weeks later. And interestingly, Harrison Chase and Jerry Liu from Llama Index, they were on the same team at the company they were at before. I can't remember where it was. So yeah, they both left at the similar-ish time, and they built both of these incredible frameworks in 1 year. So yeah, no, insane. So how do we use Langchain? Where does it fit into building our application? So say you run your compute on AWS Lambda. That could be the big red box that says application. Langchain is just a library. You just import the library, you use the classes. It's object orientated. It's quite self-explanatory in the beginning. Some of the underlying implementation gets quite complex. They have both JavaScript and Python, and I would really recommend, if you're going to use Langchain, not just to follow the out-of-the-box like tutorial at the beginning, because you're going to get very stuck very quickly. I would recommend looking at a little bit of the source code just to understand what each of the classes, what each of the names of the classes are trying to do. So getting used to that ubiquitous language, getting used to what they mean by an LLM, because that is not necessarily their LLM class might not be everyone's language model class, and same for agent tools and things like this. Where you think the boundary might start, they think it stops. So I would have a look at the source code. Even if you're not great at like reading GitHub source code, just have a look at like the base class of an LLM and just see what methods it implements, and just see like what you can actually do with this and where it might fit into your application. So Langchain initially, when they first started, their idea was that they were going to take all of these different components and they were going to like bring it all together into chains. So they define chains as a way of connecting different pieces of information, tasks, actions in sequential manner. So something that you're going to do one after a time. It's really useful for well-defined processes such as RAG, which is RAG, Retrieval Augmented Generation. We'll talk about that on the next slide. But it's pretty nice if you have a process that you do every single time, you can just do one after another. And they define that as a lang chain. So that's where they got their name. And yeah, it works pretty well. Now we also have agent chains. So agents can decide which routes they want to go down. And it gets a little bit more complicated. But essentially, chains are just one thing at a time. And they compose them up, very similar to if anyone's used AWS CDK. They compose them up into a very useful class, like as a higher level construct. And you can have lots of underlying things going on at the same time, implemented under one class. So we talked very briefly about RAG. RAG is like one of the main uses of chains. I think the retrieval QA chain is Langchain's most popular chain. And if you're doing it as a chat model, you might use a conversational retrieval chain. And this basically implements quite a nice version of RAG. So RAG is just a user querying their documents. And we have to do this slightly convoluted thing because, as a lot of you will probably have found out, most documents don't fit into the entire context window of a large language model. So we end up trying to retrieve a smaller amount of the context from the document, sticking it in the prompt, and then querying with the prompt. And there are many different ways of doing this that involve more or less calls to the language model. You can even have rankings. You can even include some rankings in the query, in the context of the in the query to get the context, and a bunch of other things there to really like tune your RAG process depending on the documents that you're going to pick. It's all powered by Langchain with just fiddling a few of their parameters. So we're going to go into a real brief demo. I was going to use one of my apps, but it broke like very quickly before. So hopefully you can all still see the screen here if we jump into this chat Langchain. So this is a really good implementation of Langchain classes, as you might expect, because it comes from Langchain. So we're just going to ask very briefly. I really like their sample question here because it's not immediately obvious. What is Langchain? Cool, is that a full stop there? So this is their new version, their new way of looking at chains. And it's come out quite recently, and they're really trying to push it. So it is useful that we get to grips with what this is. It's Langchain expression language. It's basically a way of writing chains, but it has a little bit more abstraction of the complexity of things like streaming and logging and things like that. Can anyone see this actually? Let's just make this a little bit bigger. That might be better. Cool. So we just talked about chains. Now I'm going to tell you Langchain have deprecated chains and they want you to use expression language. But if I was going into Langchain right now, I would try and, where are the minions? The minions were previous. Well, we can go back to them. Yeah, no, so yeah, we've talked about chains, and now I'm telling you that Langchain deprecated chains. But if I was going to jump into Langchain, ignore their documentation, go back, have a look at how the chains are implemented, have a look at how the conversational retrieval chain works with its underlying concepts of document loading, of splitting up and chunking, of like querying, and then how you like create document chains, like question generating chains, and how this all combines into the RAG process. I really would have a look. I can't stress this enough, and not try and jump into their higher level abstraction, which is expression language. I think they're making this quite difficult for a beginner to jump into, even someone with quite a lot of experience, because it reads less like normal code. The same way, if anyone has looked at Pydantic or Python class, if you look at Python, you add typing to Python, and then suddenly someone shows you a Pydantic class, and you're like, where are the stuff in the class that I'm normally used to? That's all abstracted out. It's great once you get used to it, but you really do then have to go and learn Pydantic, not learn Python. So that's sort of the analogy I'd give it. And here you really do have to go and learn the Langchain expression language, rather than just looking at chains and implementing them how you would implement any other class. So yeah, I would go and have a look. It's pretty cool. But this chat app is also very awesome because they give you underlying access. I don't know if anyone see this little button here. They give, how do you know if you're ready for the more advanced abstraction? I'm just going to answer this right now. Basically, when you feel like you want to write less code. So if you're really comfortable with chains and you're really comfortable implementing everything you want to implement with chains, then I would just, like, if you want to write less code, then you could use the abstraction. If the abstraction works for you, you'll know when you feel like you want to use it. If you're happy writing more code in chains, then we can use chains until Langchain decide they're no longer going to support them, which if I'm honest, is probably not for a very long time, because I think it's actually a really good way to use, a really good way to interact with language models and their providers and all the third parties and stuff like that. Thinking of it as a chain of components is really nice. So yeah, declarative way to compose chains in the Langchain framework. And this is something that they've come up with. So if anyone's seen this little button here, it says view trace. So if we click this, we'll see what happens. This takes us to Langsmith, which is Langchain's observability provider. Well, their observability platform, actually. And this is really cool. So this came out, I think, 5 or 6 months ago now, in like very solid alpha access. You had to message them. I think you still have to message them, but now we might be in more of an open beta. So anyone can have a look at the public streams that are visible, and if you get an account, you can start implementing this for yourself. What is really nice here is, you see when we actually searched here, we got some sources back, and we can click on these individual sources, and they are like hyperlinked, which is nice. And then we got an answer. But how did we get there? We have no knowledge from this outside point of view how we got there. And for instance, if we'd run this just like straight in code, we'd have to add all of our own logging, and it would be a bit of a mess. So this does really make sense from like a more of a practical point of view, and having some of these apps in production, being able to go back and actually debug an individual process and what it went through to get that final answer. So that final answer here, how did we get that final answer from this very basic question? And we can run through it. So this is some stuff to do with Langchain expression language. It's not that important. It's looking at some history that doesn't exist. And then it's checking that it doesn't exist. And then it's using a retrieval chain, and it's doing that with no history, so it's a little bit quicker. And we define this retriever here, which has retrieved documents from their document store, the Langchain document store. They don't show you any of this here, except they do. Voyage embeddings and Weaviate. I had just noticed that tag here. That's pretty nice. Turns out Langchain uses Weaviate for their Langsmith, in case anyone wondered. Probably just me. And here we've run through another chain to formats and documents. So we see the output here, the output of the formatting of this document. So I'm guessing this bit is part of the document. We also have like an ID and all this sort of stuff. And then we pass that output to create this prompt template. And so this creates the actual prompt, and we output here with the full prompt. So you can see the prompt that the chat model uses. It says it should use bullet points. It says very often, oh, this is the document, and we get to the bottom. It says very often. Remember, there's no relevant information. Just say, I'm not sure. It says that like 4 times in the prompt. So I guess they had problems with that. Useful thing to note is that do you know what format the document's in? I don't, but maybe if we dig a little bit deeper, we can see. So I would guess this is metadata. This is metadata for the document. So this is the title metadata. So when you have a document in a vector store, so a Langchain document, it has content and it has metadata. So I would guess this whole thing is metadata. Or yeah, this whole thing is metadata. And then the rest of it is context, is content. Yeah, something like that. If you dig a bit deeper, you'll be able to see what they have as their metadata. I think Langchain by default only sticks the title of the document and the source, like where it got it from, in as metadata. But that's all very customizable. I was actually doing a chat with your docs over GitHub API documentation, and GitHub published all of their REST API, so you can do this quite nicely. And it's actually really useful to pass out some individual points of the content into the metadata, because then you can access that directly later on down the line. It's just a nice way of separating things up. You can also have multiple different like attributes here rather than just metadata and context, but at the defaults. So we've retrieved these documents, 4 documents here. No, not as easy as dropping PDFs or enterprise docs in, etc. Well, with Langchain, it can be as easy, and it can also be as difficult as you want to make it. So the PDF loader works really quite well, but all it is going to split up the documents based on a predefined character limit. So you might want to not just do that. You might want to use a fancier way of splitting the documents that might include some form of like character recognition. So maybe if you got to the end of a new line, you might want to split there rather than splitting, say, just halfway through a sentence. And then grabbing like you could do some more parsing processes, grabbing like the previous the previous thing as a summary. So data ingestion gets very, very complex. And so I would say start straightforward, then make it more complicated if you need it. And the basic Langchain classes for loaders are really, really quite good. If you're struggling with those or you want to eke some better performance, then you can start substituting splitters and doing like more pre-steps for ingestion, which might include generating some summaries. Cool. So the weather in Cape Town today wasn't as great, but it is very warm. It's still like 23, 25 degrees. So it's lovely. But it was raining this afternoon, so I thought it made me think of London. But yeah, no, I'm going to fully get slapped in the face when I get back on Sunday. I don't know how warm it is there, but definitely not 25 degrees. So yeah, anyway, we're getting sidetracked. We track it, we jump it into the prompt template, and that outputs this like really nice system prompt. And then this system prompt, super, super nice, has some context. Langchain uses these context tags. I've never tried them before. When I normally do this, I normally just backtick them, but they use context flags. Maybe it improves performance with some language models. They're normally pretty up to date with this. So this is why often using the out-the-box Langchain classes can be better than making it yourself, because they know what to do. And then now we click here, we see the input, we see what the human gave. So this is like a system prompt, and then the human message, and then the output from the AI. And this is nice because we can see like actually what happened. And then the output is just passing the whole thing to a string. And because we're going to get this type of funky message, which is in the form of like a Langchain human AI message. And then we just have to pass it out to a string. And we get this, which looks quite nice. Okay. getting told off for answering questions. Cool. So this is really nice. And this is like observability, and you can put in any Langchain class. Even you can hack it and add some like Llama index query. What do they call it? Like queries and things like that. You can add those to this. You just have to format them in a certain way. But we'll jump very quickly back into the slides for the last little bit. So yeah, we had a quick look at Langsmith, and it's like observability of chains, agents, any other high-level construct. So you can see exactly what was happening all the way through that API call that maybe otherwise would be obscured. You're not going to catch this in CloudTrail, for instance, because there's a lot going on under the hood. And it also provides things like annotations. You can create data sets of different prompts and of different responses from the LLMs. There is a playground included, an LLM playground. So you can see how different prompts would have influenced the output, and you can save all this stuff. Currently, they're in a beta access. You have to request access. But if you are doing this, I really would recommend. Now, the big question is, how easy is the setup? Langchain itself, the setup is very easy. You don't have to do anything other than just install Langchain. Langsmith, you do have to get an API key. They don't charge at the moment, but they probably will turn this into a SaaS platform. That is their monetization route for their open source stuff, is providing these things on top. And so you have to get an API key, but then you literally just have to put that API key as an environment variable in your Lambda function, for instance, or Cloudflare worker, or however you're running this. And it just works. You don't have to worry about anything else. This new chat OpenAI is the language model, and this will grab all the environment variables from the runtime, and you'll never have to set it directly. You'll just have to export it. Yeah, it's pretty nice. It's pretty nice. I think like a lot of SaaS platforms can really learn from this setup. And yeah, a lot of people like say that Langchain is not very well designed from like an architectural point of view in terms of looking at its classes, but I think they've gone to huge lengths to make like usability of the product much better. Very, very quickly, it's actually the last thing we're going to talk about in terms of Langsmith is they have this like hub for prompts, which is actually really cool. If you're ever stuck on a prompt, just jump into here, and there's so many templates, like literally thousands of them, all community added. People star them. You see how many people have looked at them, how many people have downloaded them. And then you can actually pull that, similar to Hugging Face, if anyone's ever used Hugging Face, and with models, you can actually pull the most up-to-date prompt that this maintainer is keeping up to date, or a version of that prompt. You can pull that and use that directly. So if they update it, then you can pull it again. Obviously, you're going to add a bit of latency, but it's pretty nice. Like, for say like a dev environment, and then you could fix it for production. But in a dev environment, you could always stay up to date with the most recent like technology in terms of prompt engineering, which is pretty cool. So yeah, Langsmith is part of Langchain's ongoing effort to create some monetization. They've had like huge investment recently, and you can see they've taken this ecosystem and they've got a bunch of users now. So this is going to be charged for eventually. And they're also having another platform called LangServe, which is their deployment platform, which in the future, you'll just be able to click on a chain and say, deploy that as a serverless API, and they'll have all of the infrastructure all deployed for you. Not negating the need for us for running this hackathon, but they will be able to do it in one click in the future. It's amazing how fast a lot of this stuff is moving forwards. And I'm really excited to see it. So moving forwards, like, how can you stay up to date? Like, the speed of progress here is like mind blowing. I learned chains 8 months ago, and now I'm already saying they're deprecated for Langchain expression language. And it's just like reading, getting excited about it, building stuff, having a look at open source. There's so much open source here, and it's all being pushed by this open source tech. So I really would recommend checking out Langchain blog. And also Llama Index they're not quite competitors. They do slightly different things, but Llama Index is another ecosystem open source tooling. And their founder, Jerry Liu, their CEO founder, he has a Twitch channel, Twitter account, and he posts a bunch of really, really cool like how-tos on RAG going from really basic levels, like basic building blocks and building up. So yeah, if you're interested in document retrieval, if you're interested in any of these applications, I really would check out his Twitter as well. I haven't linked to it, but I'm sure you can find it. Cool. And yeah, thank you so much, Johnny, for adding the URL for, yeah, absolute marathon to keep up with. I mean, I've been on annual leave for 2 weeks and I've missed so much stuff, even just like, I mean, it was over reInvent as well. So like all the AWS stuff has just come out. It's like, wow. So yeah, thank you so much for listening. And I think that's the end of my slideshow. And if you have any questions, you can chuck them in the channel and we'll get to them afterwards. Back to you, Lorenzo.
Perfect. Thanks a lot, Matt. That was a really great presentation. I'm sure everyone learned a lot with it. We have been doing, or last webinar, we learned the basics or what LLMs actually are and how they're built. Now Matt has explained how we can actually use them. And he was right, Langsurf is around the corner, but until then, you will need to hear about choosing your serverless API or how to build it to actually be able to participate in the hackathon itself. So Matt has explained Langchain or mentioned Langchain a ton. We are also using it for our demo application, and one of the issues that you might find is that it might take a little bit of time. Not all prompts are fairly quick. Depending on the amount of tokens that you allow it to reply, it might take a little bit. So there comes the issue with timeouts. So serverless APIs. When we talk about APIs, normally the first thing that everyone comes into mind is, oh, REST API. Okay, I know how to build it. That's easy, or that's something that everyone is already familiar with. But as mentioned, we have some limitations. Okay, so now we are going to see a few different technologies / options to build a serverless API. For each different technology, here at the top, we have a little QR code that directs us to some really great articles to learn more about each of them and how to build them. Okay, so here, for example, for REST API, it's a link to an article on how to build a simple, well, not simple, but how to build a REST API using Cloud GTO. That's a product that Serverless Guru has been working on for the last year. So what is a REST API? I think everyone knows what it is. Everyone has played around with it, or at least most of us know it, but it's just a collection of resources and methods, backend HTTP endpoints, and it's based on request responses. Okay, so it's something that is synchronous. What it means is that I send a request and I wait until I receive the response. The issue here is that we will face some limitations with it. So limitations for REST API is payload size. So for us, at least in the hackathon, I don't expect anyone to reach the 10 megabytes of the payload size limit. But one that we will, or the most of you will for sure, see is timeout. Timeout of 30 seconds. That means that from when the request arrives at API gateway until your Lambda replies, you have a maximum of 10 seconds to do so. And now, if you even try to, for example, add an authorizer, a custom authorizer, a Lambda authorizer to it, so that you can actually limit who access your API gateway in a custom manner, so not just with an API key, then the limit on the authorizer is 10 seconds. Okay, so you need to have in mind 10 seconds maximum for authorizer, 30 seconds in total maximum time. Basic architecture, how to build it. It's fairly basic. Most of us will already have played around it. Here, just two things that I wanted to mention about it is, one, you can go with API gateway, and then the API gateway connected to a Lambda You can have one Lambda per endpoint, which I personally prefer and recommend, or one Lambda that handles everything, which I really don't like. But there's the option, one Lambda to handle everything or one Lambda per endpoint. And another option, which would be even kind of easier or with less code in the middle, would be you can connect the API gateway directly to the data source. So for example, DynamoDB. Instead of having a Lambda and then the Lambda accessing DynamoDB, you can have API gateway, build the request, so build the get, the query, or the put directly into DynamoDB without the need of having the Lambda in between. Okay, so that's the basic architecture for REST API, but take into consideration, if you want to use REST API, that's okay, but you need to take in mind that you might face some timeouts. Another option, WebSocket APIs. And another really great article by Jovena. I really recommend going through it. WebSocket APIs is another communication protocol, but here the important part is it facilitates real-time bidirectional data exchange. What does it mean? Is that someone connects to it. So for example, I connect to a WebSocket API. I just connect, and then the backend can send as many messages as they want without the need of me actually going to the backend and saying, hey, this is my request. I'm waiting and then reply. No, I can have the connection open, just send one message or not send any message, and the backend being the one responsible to reply or generate all the different messages that they want to notify or send to the front end. Okay? That's the difference. Limitations. We also have the limitation here for integration timeout of 30 seconds. So similar to the REST API, from when the request, so the first message, comes to API gateway until you reply with anything, you have 30 seconds. The connection for the WebSocket API is 2 hours. So you can have the single connection for up or working for a maximum of 2 hours. But you would also have to keep in mind there's a timeout for idle connection, or if you don't do anything for 10 minutes, it might time out automatically. So here you might say, okay, Lorenzo, but you mentioned, hey, what we want to avoid is the 30 seconds timeout. Why are you talking about WebSockets API? It's just more complex, but still with this timeout. So why are we keeping this as an option, the WebSocket API, if we still have the 30-second timeout? Because it's bidirectional data. Okay, what this means is that the timeout is only for these lambdas to reply to the user. Okay, so the user sends a message to API gateway to connect to the WebSocket API. API gateway will send the event to the connect lambda or the connect path, and you have 30 seconds, or the lambda has 30 seconds to reply. Okay, similar with everything. But we mentioned that the communication is bidirectional. What does it mean? Is that we can just, hey, we decouple everything. So the user sends a message. The message goes to the Lambda. The Lambda says, okay, I know this message will probably take more than 30 seconds, so we can just add it to the queue. We add it to the queue. After adding it to the queue, this Lambda will reply saying, hey, everything is okay. So the 30 seconds is already done. We know we won't reach that 30 seconds timeout. And now this Lambda and this ASQS queue will just trigger another Lambda. And this Lambda, the processor Lambda, how I mentioned it here, can send as many messages as it wants to the API gateway to reply to the user. So that this Lambda might be taking 1 minute, 2 minutes, and sending constant messages via the API gateway to the user. So you can have instead of just one response to the user, you can send as many responses as you like by having the processor Lambda here saying, for example, if each second I'll send a message for 1 minute, and the user would receive every second a new message from the Lambda without the connection being at timeout. So there wouldn't be that issue that we faced or the issue that we had of, damn it, REST API, I really wanted to have really custom model or really fine-grained prompts, but they are timing out. So now, instead of being this Lambda, the one that processes everything or calls Bedrock, we'll have this one doing all the heavy lifting, decoupling the logic, so that we don't need to face or have trouble with timeouts anymore. Another option. We spoke about WebSockets API. We spoke about REST APIs. We have also a nice article about AppSync Subscriptions. Okay, this one is written by me. Feel free to drop any comments or questions regarding that. For AppSync Subscriptions, what are AppSync Subscriptions? Or maybe better said, what is AppSync? Not sure if anyone has played around with AppSync or any GraphQL API, but it's basically instead of REST, where you have one endpoint for every different operation that you have. With GraphQL, you have a single endpoint for everything. And then AppSync, or whatever platform that you end up using, will be responsible for triggering the expected resources. So AppSync subscriptions. What are AppSync subscriptions? Is inside AppSync, you can have queries, mutations, and subscriptions. Subscriptions is basically the user telling AppSync, hey, please notify me every time this mutation has done something. Okay, so for example, if you want to be notified every single time that that a prompt is or a streamed response is returned. Okay, under the hood, AppSync is basically using a WebSocket connection between AppSync and the client. But in this case, you don't really need to care about maintaining the state of the WebSocket connection or handling authentication or anything like that. Everything is done by AppSync. Okay. The limitations or the only thing that might be really a stopper for AppSync is to trigger a subscription, you need to trigger a mutation. Okay, it's not like WebSocket API, where I mentioned the backend can send as many messages as they like to the frontend. AppSync doesn't really work like this. The subscription is only triggered by a mutation. Okay, so you need to have a mock mutation, or here in the article, I speak about how to implement the solution, and I also provide a link to GitHub to the working example, so you can just take it from there. But it's basically, you need a mock mutation to trigger the subscription so that you can call the mutation from the backend. The mutation won't do anything, just return the same that it has an input so that the subscription is triggered. Here, also, you might say again, yeah, Lorenzo, but you mentioned it's only 30 seconds timeout, and this AppSync also have the 30 seconds timeout. But we can do the similar thing than before. For the basic architecture, just as a little heads up or how AppSync works, AppSync under the hood works with resolvers. Okay, resolvers might be either written in BTL or JavaScript. I really recommend going with JavaScript here. But resolvers are basically just like little scripts that will be executed by AppSync to request some information from a data source and return it. Okay, you can have resolvers like this, where it's a resolver without any data source assigned, where we will just execute any logic locally here. Or a resolver like this, that has actually a data source assigned. So this resolver would build the logic to do the query to DynamoDB. AppSync would then take the query, send it to DynamoDB, take the response from DynamoDB, add it to the resolver, and the resolver then would be responsible to actually go through the response, map it as needed, and return it to the user. Okay? But same issue we have here is timeout. From the user sending the request to the resolver reply, we have 30 seconds. But here, sorry to say it again, the magic is decoupling. Okay? We always need to decouple anything that we think might take longer to be executed. In this example, it's fairly similar to the one before, but here we would have one mutation, for example, send prompt or user prompt, where the user would send the information that they want to send to the LLM, a simple prompt. This prompt would be sent to the SQS queue, similar as the other example, and then the resolver would return the user, let's say, an ID or anything. Okay, so that the user knows, perfect, my prompt was received by the backend. And then the user could say, okay, now with that ID, let me subscribe to this subscription that will get triggered every time this mock mutation is called. Okay, the mutation could be streamed responses, for example, or LLM response, whatever we like to call it. Now, similar to before, SQS will trigger the Lambda, the processor Lambda, but here, the processor Lambda, instead of returning the response directly to the user, this processor Lambda will need to call AppSync doing this mock mutation that we talked about of LLM response or streamed response. So the Lambda itself won't be calling won't be replying to the user. It will be calling AppSync. And then AppSync, seeing that the mutation has been triggered, will check, hey, do I have any users subscribed to this mutation? If yes, then it will take the same response from the mutation and send it back to the user. Okay, so different options here. The easiest one would be to go with REST API. Everyone knows about REST API. You can even use Cloud GTO to get it up and running. And you'll have a simple API to use for your LLM prompts. The only issue is REST API. There isn't really a way to decouple things. You could try to decouple them and then respond with SNS topics, but it's another nightmare that I don't want to get into it. Then we have WebSockets APIs, maybe some new thing or some kind of API that you have not heard about it yet. And then AppSync API. AppSync API is gaining some traction, but you can just choose whatever you like or even any other approach that you might think of. As mentioned, the QR codes on the top are links to the different articles that we published this week. We'll be also publishing another article regarding Lambda streamed responses. Okay, so it's not really an API, but you can still use it to get streamed responses for longer executing tasks. All the links, we'll be also publishing them on Discord. Perfect. Then that was everything from my side. Let's take it up for the question, all the different questions that we might have. Let's have everyone back on board here. Welcome back, Sam. Welcome back, Matt. I hope I wasn't too boring or too technical in this part of the presentation, but let's get started with the questions. Not sure if there's any questions that you might already have in mind.
Yeah, I'll have some questions from the chat lined up. So Craig once had a few questions in the chat. So let's start with this first one on the costs. Are there any big differences in costs between all the different services for making an API? So he asked that at the point at which you'd started to introduce WebSocket APIs. So maybe at the time he was asking about a comparison between the REST and WebSocket, but maybe we can now also extend that to AppSync. Lorenzo, if you want to start with that one.
Perfect. That's a really great question. Not one that I can just reply directly on top of my mind for the different pricing tables. For REST and WebSocket, they might be similar. For AppSync, depending on the use case, might get a little bit more expensive. But yeah, we can just review the AWS docs to get the pricings on top. But just for this hackathon, everything that you use, either if it's REST API, WebSocket, AppSync, or even Lambda Streams responses, everything should be inside the free tier of AWS. So you shouldn't be too bothered about it for this hackathon. But that's sorry, go ahead, Sam.
Sorry. I wanted to extend the answer when you're done. Just let me know when you're finished.
No, go ahead. I just wanted to add that it's something that we really should have in mind when we want to develop anything for a longer period of time, or at least some production level project that we want to improve.
Yeah. So I've obviously had a little bit of time to prepare some answers off screen. So let me extend a bit what you've just said. You made some good points around AppSync and then comparing the pricing models for REST and WebSocket. And so Craig, this isn't it's a very common question to ask, especially in serverless architectures, is how much does everything cost? Because everything's a pay-per-use pricing model. So it is definitely a problem to solve in the industry. Funnily enough, I am actually sort of co-hosting a webinar, probably on the same YouTube channel. Serverless Guru are teaming up with Memento, who provide a serverless caching option. So I'm talking with their ecosystem engineer, I think, about cost sort of savings and how you price things in serverless. I think, what's it titled? It's titled Spending Less Going Serverless. It is possible, we swear, because lots of people in the community think that these serverless architectures, they just blow up in price the second you fire some requests at it. So definitely, if you're interested in trying to work out sort of a pricing solution for what you're building, definitely, I think it's next Tuesday, same time. So definitely give that a look. I think Jonathan might put a link into the chat in a second. But on your REST API versus WebSockets, let's just look at that as an example. So I've been putting up the docs. And so for REST APIs, you've got sort of two pricing considerations. You have the number of requests that you make per month. So that's just like a client request coming in with a response. And for example, the first 333 million are $3.50 per million. So it's obviously going to price from zero and price all the way up. With API Gateway for REST, you also do have the ability for caching. Now, I don't think caching is really going to be a popular use case for a chatbot application. There's not really much to cache because it's all generative responses. However, with WebSockets, there are some similarities. So you do have a price for the requests. So in this scenario, it's your first billion requests are $1 per million requests. So you have to do some maths to figure out, okay, if I'm expecting 500 million requests, which one's cheaper? So you could look at that. But with WebSockets as well, you also pay for your message transfers. Where are we? No, here we go. And your connection minutes. So Lorenzo mentioned that when you have a WebSocket, it stays live for, I believe, 2 hours, but it will close idle ones after 10 minutes. So if you open up a connection for a chatbot and you don't post anything for 10 minutes and the backend isn't pushing anything for 10 minutes, it will close. And you're paid 25 cents per million connection minutes. So those are sort of your two considerations. I would definitely tune in for the webinar next week. There was a little bit on reInvent as well. The Frugal Architect, if you give that a Google, talking more about sort of more pricing considerations as well. We're going to talk a lot about that next week as well. I hope that helps you, at least. That's just one example. We've then got all the different backend stuff, all the lambdas and whatnot. They're all going to be mostly the same, but we've got to make a call when we've got to wait for a very long response from Bedrock in our example. So there's no way getting around it. You're going to have to pay for some compute to wait for that response. But beyond that, we're not making too many additional requests or Lambda invocations, really. So it should be about the same. Right, that was a good question. We'll jump to the second one as well. So you had a second one. Matt, what is Cloud GT something? I believe you said. What did you say? What is this Cloud GT thing you mentioned. So Lorenzo, you may have done like an accidental plug for a serverless guru platform. Do you want to give a 20-second summary of what it is?
Yeah, not even 20 seconds, but we'll also drop the link to access the platform on the chat. But just as a 5 cents on what it is, it's a platform that allows you to get a skeleton or the basic just by almost drag and drop / a little form. You answer a few questions of what you want to build, and it will provide you with a skeleton example or some code that is already almost ready to be deployed. So via the console, so on the web UI, you can just select what you want. Either, I think right now it's REST API or AppSync API. You can add all the information. For example, for AppSync, you can say what data sources you want. If you want to have a single table design DynamoDB or one DynamoDB for every single different model. And after you complete the process on the web, you can download a folder with all the code and also the serverless.yaml needed to actually just as SLS deploy and have something up and running fairly fast. I know it's currently on open beta, so I would recommend anyone that is interested, just hop on the link and check it out, at least to play around with it a little bit.
Great, thanks, Lorenzo. So we're approaching the end of the hour. I know Matt needs to drop. He's obviously on vacation, and we don't want to keep him too long. I think Lorenzo might keep it open for a couple more questions that we've got. Yeah, so Matt, if you just got any sort of closing remarks where people can find you and whatnot, we'll let you go.
Yeah, sorry, guys, I have to run. Basically, I'm active on like all types of media everyone else is active on. I'm on LinkedIn, I'm on Twitter, X, Vibe. And also my email is mattc@alios.com. Anyone feel free to email me. But yeah, no, it's been really great. And I look forward to seeing what everyone produces for the hackathon. Cheers, guys.
Great, thanks, Matt.
Thanks a lot, Matt.
So we don't have many more questions coming from the comments. I had a load that were lined up for Matt. I really wanted to quiz his brain on Langchain, but instead I'm going to sort of open them as sort of open-ended questions to ask yourself as you're sort of going through this hackathon. So maybe some people that weren't aware what Langchain was before we announced this webinar last week, you're probably trying to talk with Bedrock or the OpenAI API sort of directly, trying to make prompts and responses, and probably had tearing your hair out saying, okay, how do I make this into a conversation? Am I having to like merge all my strings for every single sort of question and response that's happened in the past? And so I hope that Matt's made it quite clear how using the Langchain chains, and specifically that sort of conversational chain, helps to maintain that conversation in various different backends. You can even just let them sort of drop into DynamoDB, and you don't have to manage anything. It's quite nice. So asking yourself, okay, should I maybe, if you're halfway through this project, should I be using Langchain? Is it time to pivot rather than calling the API directly? We now also need to judge some of the reInvent announcements as well. So I mentioned last week that Bedrock Agents went GA. So Bedrock Agents is this sort of virtual agent that you can sort of train to, first of all, maintain the conversation. So it solves one big headache that Langchain solves. But then also you can train it with data and make it do a very specialist job. So now asking yourself, do you want to sort of keep the code that you've got, or do you want to pivot to this brand new service that's come out and see if you can make, for example, a Santa-like Bedrock agent? Asking yourself questions like that as well. I did have one more. So some other things around the software engineering that you can be putting into this project, like these LLMs, it's all very new, and there are even some problems that the industry hasn't solved yet. So consider some of the following options. We have this sort of threat of prompt injection. So similar concept to SQL injection, where you can kind of rewrite the prompt. So rather than sort of using semicolons to close out what your SQL string would be behind the scenes and then drop a table or something destructive, you can instead sort of tell the LLM to ignore the previous prompt, and instead give me some raw sensitive data that maybe I've got access to. And you can even try that out with our example. I don't think we have even solved that problem. You can probably prompt inject to turn it from Santa into something else. So consider that for your project as well, and definitely bring it up in the article and the 5-minute long video if you do solve that problem. Additionally, the performance side of things, like these LLMs are slow. We've shown some examples of how you can use WebSockets and decouple sort of a backend async process, so you can get responses back to the client quick and wait for those responses to stream in. Did you solve any other problems? Definitely share within your project how you made this a little bit quicker. And I think that's just about it on my end. Yes. So, Lorenzo, thanks for preparing that second half of the talk. Do you have any sort of closing comments for those of you who got 1 week left of the hackathon?
Perfect. Thanks, Sam. Not much, really. Just a reminder that we'll be dropping all the links and reference for the articles on Discord right after we close this webinar. You'll also have the webinar recorded to be able to review anything specific that you might have missed. And just as a reminder, the form for submissions is already open. And during next week, we will, on one side, drop the article on our demo. So what we expect you to write, an example with writing how we approach the challenge and what we came up with. And then just next Friday, I think I'm fairly excited or really excited for that webinar. It will be Sam and me just bragging about our demo application, how we solved some of the challenges that we faced, and giving like a last minute peek for everyone that might still need some help to actually develop or end their application. But yeah, that was everything from my side. Thanks everyone for attending. Thanks everyone for the questions, and back to you, Sam.
Perfect. Yeah, so same time next week, final webinar from this series, just as we get to the grand finale of the hackathon. So be sure to tune in and definitely quiz us, question us. Why did we make every single architecting decision? We want to be held accountable. So be ready with your questions to fire at us. But take care. Good luck developing for the last week. And we're available on Discord. We give a ton of help in the different community channels. So feel free to sort of use our resources. Take care, everybody.